Read it 5 times.
Okay, all right. Looks like we're going to get started. So everybody, welcome to the Cool Code Consortium. Hey, Tom, can you confirm that you can hear me?
Yeah, I can hear you.
Okay, good. All right, so we're coming through. We did put a poll in the Slack, so vote now on your phones. What is an exciting thing you're doing for the 4th of July? So there we go. So yeah, so we'll do some announcements. I think I only have one announcement. It's the same announcement I had last week. Yes, and then definitely make sure you do the poll, because so this is a new thing we're introducing this week. So we'll announce the poll at the beginning, and then at the end we will list off the poll results and who won the poll. So okay, so make sure you actually vote in the poll this week. We're going to move on to cool news, and then we're going to, cool news, Lewis has some cool news he's going to talk with us about, and then we're going to do some advanced / scalable databases. Chris has got some good information for us on that. Then we'll talk about next week and the results of the poll. So, all right, here we go. So the only announcement I have, again, we have a GitHub repo. So if you're interested in demo code or slides from any of the meetings, you can go here. I've also linked this into the pinned comment in general, the general channel, so you can go up to the top of that. Another announcement that I just thought of, we just had a request today come in to record the meetings. So we're going to attempt to do that today. So Chris is helping us out with that. And to that effect, I'm going to post the YouTube channel for this later. So these, you can go back and learn some stuff. So this, we're gonna try, and hopefully for a couple weeks we'll have a better recording solution. But that's what we're gonna try to do. And with that, we'll move over to cool news, and I'll let Lewis talk about this. You can. So I'm going to just move this over to the other screen. Oh dear, I clicked on an ad. All right. Not blocked? I don't know. Yes. CNET wants to show notifications. No, thank you.
It keeps asking for notifications, like multiple
cookies. Look at this.
Install some ad blocking.
Okay. All right. So I'll just give that to you.
Yoink. I'll just sit here. Right in front of the snacks. Okay. All right. Hello. You probably can't see me, actually. Okay. So for those of you who haven't heard, Google somewhat recently announced what they call Google Duplex, which is, you might say, the logical extension of Google Assistant, where you can just say, hey, Google, please reserve dining reservations for me at Taco Bell or whatever for 6 o'clock tonight.
Whether or not it does it is a different story.
Yeah.
I really want to tell Google to do this now.
It's not mainstream yet. Sorry.
Reserve a table for two.
Making reservations at Taco Bell kind of feels like demolition.
Yes. You can totally try that eventually. So the idea is that you tell your Google Assistant, hey, please do this. And then the Google Assistant, there's a nice little flowchart down here. The Google Assistant talks to the Google Duplex servers. The servers put in a call to the business with a handy-dandy robot voice. And they have a conversation with the business. They do whatever task you ask them to do. And then they eventually report back and say, yep, it worked, or nope, it didn't work. You should swallow your fear and shyness and actually make a call to another living human being.
No, thank you.
They can try. Yeah.
T-Mobile ads in Spanish.
That's a really good question.
Connor, have you been searching things in Spanish again?
I could have been searching.
Definitely searching something in Spanish.
Okay. So that was from probably a month or two ago. I don't know. But the more recent stuff is. Did you open the same link twice?
Webpage.
Oh, hit the background.
Connor!
I don't know.
Let's be honest, it's hard.
I mean, I can maybe
Try the first
try
10.
the first 10.
I can't click is the problem.
Oh, it's. You mean
I don't know.
you can tap.
Forward.
Oh no, there's.
There we go.
There we go.
Okay. And I'm just going to mute this thing in advance. Goodbye. Oh, it's automatically muted.
Oh, is it a video?
It is a video.
Okay. Well, I think you can unmute. Rust here.
Okay. We're not going to go through all this. Stop that. Okay.
So let's see if we can.
Okay.
Yeah. Play that. Actually calling a real salon to schedule an appointment for you. Let's listen.
Yes.
This is good.
I'm looking for something on May 3rd. Sure. Maybe one. Depending on what service you would like, what service would you looking for? Okay, we have a 10 o'clock. 10 a.m.
Yeah. So one of the big concerns when that thing first released a month or two ago was that this is extremely creepy. How do people know that they're talking to a robot? What about laws and stuff? It's a thing.
What laws could that potentially be breaking? Like,
Recording.
okay,
Oh, yeah.
so it is like
Yes,
a
so
two-party
there-
consent.
Yes, there are laws that apply very much so in this case. So they released this more recently, which show more updated version.
Hi, I'm the calling to make a reservation for a client. This automated call will be recorded. Can I book a table for Tuesday the 12th?
I love the look on his face, by the way.
How should the system translate itself? And the way that we think about it is really having four
See.
elements. First is
You don't care about
start
that.
and so they play some really important purposes in our system called float state.
There was.
And so as we kind of study that and look for ways to make it natural, we came upon this idea that linguists call speech disfluencies, as ums and ahs, that we all use our everyday conversation. As linguists have studied this, they found that those words or non-words actually play a crucial role in helping the conversation. And so they play some really important purposes in our system, help both sides of the conversation kind of know that the other side's still listening, or introduce things like corrections and clarification.
Hey, Google.
All right. So the beta is still very, 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 very much closed right now. Like they are working with a select group of people and a select group of businesses. And if you're not part of that teeny tiny sample size, you ain't gonna use it. So stay tuned for more. But this is coming down the pipeline. So be on the lookout.
Right. Good stuff.
Humorously enough, that legality concern totally would be a non-concern if Google were based in Indiana, because Indiana is a one-party consent recording state. Which means that if you're really paranoid and you want to wear a wire microphone everywhere you go, you totally can. It's totally legal.
Not gonna say.
In the state of
Does it
Indiana.
matter if the other person is in another state, though?
Huh?
Does it matter if another person is
I don't know.
I would assume so.
Yeah.
All right, we move on to advanced scalable databases.
Oh, hey, this thing. What do these buttons do? We'll find out. Advanced scalable databases, that's a thing, right? So what I want to do is give you kind of an overview of what kind of database options there are out there. So the majority of people will be familiar with SQL. And pretty much only SQL. Ever, forever. There are so many more fun options out there, and I want to go through some of the types and then give you like an example of what each one of them are. And unfortunately, I don't have any kind of fancy demo because there's just kind of too much here, but yeah, we'll get there here. So in our first couple of weeks, we looked at sort of sticking your stuff off in the cloud somewhere and communicating with stuff off in the cloud somewhere. And so, another part of your big application that you're developing is data. Everybody's got data. Where the hell do you put it? Well, you put it somewhere. And right, it's got to go somewhere.
Can I put it in a file cabinet?
You can, and you can put a person to sit there and just kind of like, get responses, and then it'd be very, very hard. But yes. So we want to look at sequent solutions, right?
There's another name for that.
No, I looked that up. That's correct. So some of the key things when you're looking at NoSQL databases is that the benefits are largely going to depend on which NoSQL database you actually look at. So like I'm going to talk about 4 different categories of them, but within each category, there's going to be several different types or several different implementations of that, and they're each going to do their own thing differently. Generally, with NoSQL databases, they're looking for high availability, scaling this thing up massively with minimal downtime. And then one of the fun things with NoSQL databases is that they do this eventual consistency where you can write something and you don't necessarily get that write to be persisted right away. So they can take a lot of writes really quickly, and you don't necessarily have to worry about that because it will eventually catch up. So that's a different concept between the SQL databases. And then, yeah, again, to reiterate, NoSQL databases within a category very much going to have their pros and cons. So I guess let's see. Just jump right in here with some document stores. So if you like JSON, you like document-based stores. So some of the cool things about these is that you can do structured data or semi-structured data. So for instance, if you have another document that looks kind of like that one up there that maybe doesn't have a contact, most of the document stores will let you do that. And so another thing is you can do sub-documents. So you can get nesting on your data that you can't get with a SQL database. So in your SQL database, you'd have like one table that would say, okay, this has this contact, and it has this contact, and it has this contact, and you have to go and do some kind of crazy join to get all of those. With here, it's right there nested. So some of the problems with this is that a lot of times when you say there's a field called contact and it looks kind of like this, your developers, whoever's putting data into this, can pretty much put whatever they want there. There's not a lot of, what are they called in SQL? Integrity constraints, I believe, right? There's not a lot of that there. And you'll get that with a lot of these NoSQL databases. They're designed for less structure. As a result, you may put more information in here. So you may have like a whole nother store that does phone numbers and lets you look up the actual object here. So we're looking at, like, I guess, a user. So you may store more data, and you may store the same data in different ways, depending on what you want to do with it. So when you're doing document stores are usually a pretty good general store. They tend to be a pretty good catch-all. A lot of people tend to just throw whatever they can at something like Mongo. The Rose Build team did it. They probably shouldn't have. And also, you can store like just straight up binary blobs inside of one of these fields. And if you want to work with something like JSON or XML that's in this highly structured form, these tend to work rather well. And so the class example of one of these is MongoDB. This would be like the #1 NoSQL database probably that everyone's heard of. MongoDB has some benefits in that it likes to give you one interface to work with no matter how you scale it or shard it. So you can put different Mongo instances on several different machines and kind of replicate your data across those, and Mongo will provide you a single interface. So in that way, Mongo is really cool. Mongo doesn't have its own query language. It does the shell, and there's a lot of different drivers that are implemented in other languages. One thing that Mongo is fun with is that you can actually pretty much insert your own JavaScript into it. So there are certain parts where, like, if you want to filter on something, you can insert your own JavaScript in there and do the filtering. It also supports granularity in that you can find a single document, find all the documents. You can sort on arbitrary keys. Although I will say Mongo is not so great at sorting on subdocuments. So if you go back to this and you wanted to sort all of these users by their email addresses, you can probably get it to work. It's going to be a little bit more difficult. Mongo doesn't like doing that very well. So those are document stores. I guess it'd probably be better to ask for questions in between each kind of category, because I'm going to bounce through this quickly if I don't slow down. Document stores.
So like the biggest pro and the biggest con of a document.
The biggest pro is generally the ability to do the structure with these things. So a lot of what you do is in your REST requests, whatever, you're sending JSON back and forth, you're sending stuff like that. JSON gets passed around a lot, and this stores JSON perfectly. The biggest con is probably going to be in that if you're missing fields, things might act weird. If you don't check what's going into those fields, things might act weird. You just have to handle that logic at the application layer and not at the DBMS layer. Your database management system will not catch that for you. So the next one is hash map, essentially a giant freaking hash map. So key value store is literally a key and a value. These are very fast. It's a hash map. If you were to sum this up, one word, hash map. So these aren't complicated. Sometimes they'll let you do basic data types, so you can do like a key to a list, and then inside that list, you put whatever you want. So one of the major problems with these, and I would say the biggest problem with these, is that if you want to store anything complex, it becomes a major pain in the butt. So for, say, you have a single user that has a bunch of phone numbers. You may have a key with their username or their ID or whatever that links to another hash map that's got like their name in it, their address, things that are constant. And then you may actually have to have another hash map that has their username or ID to like a list of phone numbers. So you may have to do something a little bit more hacky, or at least it'll feel more hacky, to store complex data. And then another thing with these is that these tend to have consistency problems because everyone's trying to get at the same key and change them. And since they're so fast, like you can see a change go through, or not see a change go through rather, if people are hitting it really quickly. And you tend to use these when you have something simple that you need to store. You need high throughput. Again, these are very fast. And these are good for data caching. And so the one that I like to talk about, the one that gets used, is Redis. Right? So Redis has its own quirk in that it's a main memory store. So this one doesn't persist unless you configure it to. And you can configure it to persist based on number of operations per, like in a certain amount of time, or you can have it on just a certain time, or you can manually back it up. It is so unbelievably fast. You're talking 700,000 operations on a key per second. That is insane. They recommend you have a really strong password because the amount of password attempts that you can do to this in a second is insane. It's insane. Like, have a good password on this one because they can just run through 700,000 passwords in a second very quickly. And yeah, that's just one of the numbers I found. I found numbers going into the millions of operations. It's insane. This is a great caching layer. It's good for queuing, so you have data that you're processing, throw it into Redis really quickly, pull it out of Redis, and then delete it. You can actually put timers on keys for the queuing. So like you say, oh, I only want to have this persist for 10 seconds, and then like if it's not been processed by then, it's no longer valid, so just kill it. So you can set expiration dates on the keys, basically. And this is also good for pub sub. So if you want to pass messages between applications, throw it in Redis really quickly, have somebody else read it from Redis, and because you can do operations, you can pull this fairly easily. If you want to do another thing with pub sub, Kafka is also pretty good with that. And that's a similar sort of thing in that it's main memory, but it's not really a key value store, so I'm not really going with that. And I see now that I left the wrong link on this. So if you just if you replace that with Redis, I could do that. Replace that with Redis. I'm pretty sure that's the right link. Good job, me. So questions on the lovely hash maps. Does anyone not know how hash map works? I can explain that.
What specific hashing function do they use?
That depends on the implementation.
Good answer.
Yeah, you have to talk to the guys who actually made it.
So can I ask the same question? Biggest pro, biggest con?
Biggest pro, fast as all hell. Biggest con, complex data, don't bother. Like this right here, you do not want to use for a main memory store. You don't want to put your main data here. It's awful. It's terrible. I made Colin do it. Bad. To be fair, he didn't stop me. It wasn't my fault entirely. But yeah, if you want to talk to him about how much of a pain that was, be my guest. I didn't touch that. I got to actually play on the Columnar Store. These are fun. So if you want something that's NoSql, that looks deceptively like SQL and will confuse everyone, this is what you want. So the idea is, in your SQL database, you're looking at rows. In a Columnar Store, you're looking at columns. So, for instance, up there in the top, there's a great image that kind of gives you the difference here. So like if you were literally storing this in a text file, you would see it kind of like this, where the rows are stored one after the other, everything's together. And in the column database, the columns are stored separately, and each row in the column corresponds to the same entry. And there's other fun things that you can do with these. These can get fairly complicated fairly quickly. The benefits, the major benefits here, the main pro, so you're going to want to ask that. The main pro here is that you can optimize the heck out of some queries. These are great for data warehousing and data analysis. For instance, here, if I want to find the average age, I query the age column by itself. I don't look at anything else there. So I don't have to pull all of the other rows up, pluck out the age thing. I can grab just that column. So any kind of aggregation operation is going to touch a lot of one column. Very, very, very good for this. Some problems that you may find is that if you scale this up to be fairly large, writes can be slow because you're essentially writing to each column every time you put in a row. And the other thing that's probably the biggest pain with these is actually designing them correctly. Because again, the instinct is it looks like a row. I'll do the same thing I do for SQL, but you want to optimize this for the queries that are going to be run on it. And the one that I would like to talk about is Cassandra. Cassandra is awesome. And it's not age-based. Sure, that's disappointing. So one of the great benefits of Cassandra is that scalability is a breeze. So it's like that picture over there. Each ring that you see is its own data center inside of a larger ring. And so with horizontal and vertical scaling, I may get this backwards. Horizontal scaling, you add another node to that ring, and you literally get that many more requests. Because so a lot of these NoSql databases tend to do the same thing that a SQL database will do when you scale. You have a single master that you write to, and that sends the write out to all of the slaves. That tends to be the architecture for most of these types of databases. Cassandra does a different system where all nodes are considered equals. You can read and write to any of these nodes. And they will use a Paxos algorithm to figure out how the writes go through. It's just a fun tidbit. So literally adding a new machine gives you that much more performance. It's not a bell curve trade-off. It's a straight line. And if you want to go vertical, you add another ring. And these rings don't have to be in the same area at all. And they can sync up. You can do virtual partitioning on the rings and have like two in the same area, but they're different rings. They do different data. So you may get slightly different data between them. You do all kinds of crazy stuff with these. Cassandra is known for its incredible high availability. It is very hard to take this thing down because you would have to shoot every single node in the head. And they offer CQL. which is just like SQL except not. The queries in SQL look exactly like SQL. I mean, they're literally just the same. I should have put an example here, but like it's literally select star from table, right? Except that you can't do certain things. So, for instance, trying to do like select star from name where like something, you can't do those unless you specifically tell Cassandra to index those. And setting up those indexes can be fun. And it won't let you do that because it says, I can't guarantee that this query will run quickly. No, like in the command, the prompt, it will tell you, I can't guarantee that this will run well. You don't want to try that. Don't do this. Just don't do this. So that's this one's a really cool one. Totally recommend you check this one out. This is fun. This is a fun one. That's a hand.
That is a hand.
Okay.
Are there some of these that you can query directly with, to be clear, between the two SQL? That like the language is literally SQL. I mean, you might get those types of warnings for things, but
Oh no, I mean like the select star from where like that works in SQL. It just may give you a warning that you need to index that column.
okay.
So like create table, key value or type name, whatever, like int name. That's terrible. String name. They are almost identical in the way that they look.
So if you didn't know,
You did not know the
You
difference.
could look at the interface to one of these column stores, and you wouldn't really know whether it was row-based or column-based, except by perhaps like the idiom of the queries, not by the actual syntax.
Right. A lot of the columnar stores support a SQL-like interface.
Okay.
They strive to be as close to that for compatibility with people who don't know NoSql. So I know, Connor, you said you're working with Phoenix on top of HBase.
Yeah, at the end, I'll ask a question about that.
Okay.
Similarly, I'm working with Redshift,
Right.
which is columnar.
So a lot of these will offer a SQL-like interface on top of their standard query language. With CQL, you can do a lot more than you can with the SQL version of it. There's a lot of extra commands, and there's certain things that won't quite work. Cassandra, again, be very careful how you structure your data. If you go look for their documentation, I think it's still fairly poor on the main website, like the cassandra.apache.org. But if you go find the DataStax website, they've done a lot of stuff. They've got a lot of videos on Cassandra. They've got numerous tutorials on how to format your data to make this right. Because if you format your data right, these queries will be incredibly fast. If you format your data wrong, you're going to be waiting stupid amounts of time. And Cassandra is designed to be scaled up, so you don't want to be waiting forever when it's that scaled. Is there anything else that someone would like to ask about a Columnar store in general, or Cassandra?
You mentioned Paxos or something?
Yes.
Or, like, what is that?
So the fun thing with these is that since you can write to any single node, say I send two different write commands that I want to change. So Connor's in our database, right? But it turns out we spelled his name with an E and not an O. So we need to correct that. So we have two different people try to fix Connor's name, and one of them makes a typo. And they both hit the database at the same time. Who gets to be written? How do we know that this write was accepted? Is one of the other things. So if I just let it do, like, I guess the natural thing would be, okay, well, I got a write. I'm going to tell all of you guys in the room that I got this right, and you guys are just going to accept that that's true. And then somebody else is going to say, Connor's going to say, I got a write that it should be an O. You guys fix it. So there's kind of a discrepancy between which write should even be accepted. So it's part of the Paxos algorithm. Basically, they elect a possible write. They say, okay, I have a possible write. I'm going to propose this write. And I'm going to hand it to you, and I'm going to say, okay, will you accept my proposal? and then you'll either accept it or reject it based on timestamp and some other fun factors that I'm not going to get into because it's a fairly complicated algorithm. But basically, you'll say, I'll accept this, and I've told you now not to accept anything that conflicts with this, basically. And you'll pass it off to the next person in the ring, and you'll hand it to Walt, and Walt will be like, I'll accept this or I won't accept this. And you go around the ring until a certain number of people have accepted it. And once they've all accepted it, it can then be written to the actual database. So the write's been confirmed as being received. So one of the things you don't want to have happen is we have 5 nodes in the ring. We get the correction on one node. We get a wrong thing on the other node, but they never talk to each other. So this now has a different set of data than this one. So that you agree to write it using the Paxos algorithm. Does that make sense, or did I butcher that horribly?
I think it makes sense.
Okay. Good. Well, let's talk about graphs. So graphs. It's a graph. It's a hash map. It's a hash map. Okay.
So for those who are less familiar with graphs, graphs contain 2 sets. One is a set of nodes.
Yes. So we have nodes.
In terms of dots and lines.
I'm sorry.
Okay. So we have dots and lines. So in a graph, we have nodes that represent entities, and then edges are relationships between those entities. We have. Would you like me to use dots and lines? Is that what?
I'm just being a shit.
I'll stop right where I'm doing. I'll go correct the slides and come back. So you graphs. It's a graph. So one of the best benefits out of a graph is that it's already in a graph form. And the graph algorithms are usually already implemented for you. So, that algorithms class where you might have learned Dijkstra's algorithm, who cares? It's already done for you.
So can we talk about some of those graph algorithms that people might be interested in, like the graph binding algorithm?
I will get to that on the next slide, probably. If I don't, bring it up then. Right, so a graph store, your node is like your object. It's like, okay, so this is a graph of friends, okay? So the purple dot in the top left is friends with the blue dot in the top middle, right? And the relationship is a friends with relation between the two people. So one of the things that you might want to use a graph store is if your data already looks like a graph. One of the things you don't want to do, and I've actually got to look at some of the code that did this, and it was awful, but you shove all this in SQL, pull it out when you want to use it, reconstruct the graph, and then query it. It's dumb. Just put it in a graph store. It's already a graph. And so you might be thinking, how could I store some of this other stuff? The entities, you can actually put attributes on the entities most of the time. So you can give the purple dot up in the left corner a name. We'll call him purple dot in the left corner. You can do a lot of fun graph stuff, and I'll show you one of the more powerful graph databases in a minute. There's not a lot of good ones of these out there. I will say that now. This is not an easy thing to do. But one of the other things to keep in note is the biggest problem with this is that some of your more standard queries become a little bit more complicated or a little bit slower due to how this is stored. Sorting is kind of weird. Sorting on arbitrary elements is kind of weird here. The number one use case for this is the recommendation engine. Thinking friends, thinking recommending books. Anything where you want to say, these two people have something in common. Let's follow this relationship and see where it goes.
Or maybe movies.
Or maybe movies. Nudge, nudge. But yeah, good use cases. Yeah, that's a terrible idea. For instance, right? If you wanted to do, you know what? I'll get to it in a second. We'll get to it in a second. So Neo4j is probably the best graph database that's out there. The one downside with this is that they do not offer scalability with the free version. So you can set up a single node instance free. The moment you would try to put more there, you're paying money. And it uses the wonderful, wonderful query language Cypher, which is a pattern matching language. So here you see a Cypher query and the return. So what you ask Cypher to do is you ask it to match something. Here we're asking it to find the shortest path between, and you see in parentheses there, the first thing is a node, the brackets in the middle with the star dot 3. That's a relationship. And then the other one on the end is another node. So you're asking for the shortest path between a movie called The Matrix that is between 0 and 3 relationships to the movie called Cloud Atlas. And the thing before is just naming it. So it says call this entity matrix in case you wanted to return just the matrix for some reason. So you can do pattern matching like this. So shortest path between 2 nodes, that algorithm right there, you don't have to worry about it. It's done. It's given. For another great example is of why you might want to do this is, let's say you want to do 6 degrees of Kevin Bacon, 7 degrees of Kevin Bacon, whatever. And you want to figure out like all the actors that are within 7 of Kevin Bacon. You can just ask Cypher to find that for you by detailing out this little path. And you don't have to worry about trying to pull that out of a SQL database or doing a 7-way join on a SQL table, because that would be awful. Right? Because that's how you would do it. You would store movie and actor, and you would store like probably the actors. This actor worked with this actor, and you'd have like a binary pair.
Oh yeah,
And you do.
You fucking love it. Can I cuss on this? Sorry, keep going.
And you do a 7-way join on that same table over and over again, versus one query that pretty much you're telling it exactly what you want to look for. So your Cypher queries are much easier to read. So this can do stuff like shortest path. This can do stuff with arbitrary paths. So for instance here, if you just asked for some path of length 5 between these 2 movies, it would find some way to go through one of the actors in the Matrix, through another movie, through another actor, however it has to do it to find Cloud Atlas. You don't have to worry about the logic of that. And that's fantastic for these graphs, because who wants to figure out how to write that? Who wants to do a depth first search by hand, Not me. I'd rather just ask Cypher to do it. And so what other graph algorithms were you
Yeah, so speaking of depth first search, we can talk a little bit about that.
Depth first search is not a problem here, because of the way Neo4j handles this. You don't actually have to do that search. It will index. So for instance, here you see these say matrix : movie and Atlas : movie. These are already of type movie. So if you ask it to give you a node that's of type movie, it has that indexed. So we can grab those already. It's already cut down most of the nodes you need to look through, because of how this is stored underneath, which is its own thing. But you don't need to do the depth first search. You can actually just pull back those, and if you do it right, and you're saying you're going to do a depth first search on like the title, you can have it index the title, and you don't have to do crazy searches that's going to go through. Because I think this database has, I don't know, a few thousand entries in it, something ridiculous. And doing a search through that, just starting an arbitrary node, would take forever. So these graph databases can take advantage of indexing to speed up some of those graph queries. And then, it's still the whole added benefit if you don't have to write it. I can't stress that enough. It's great.
Does this support weighting of edges? So if I wanted to say like a movie is really closely linked with its director, but not that closely linked with like the guy that held the boom mic, like could I weight the edges?
Absolutely.
Okay.
What you can do is on the relationship, there's not an example here, but just like how the movies have a title, the relationships can have a type, or you can have a rank with it.
Mm-hmm.
And you can ask for, say we give, we put people in here and they're rating the movies. You can have a rated by relationship going from the user to the movie, and you can say they rated this 3 stars. And then inside this query, you can say, find me a path where rated by is greater than or equal to 3, and that'll give you any path that does that. And you can return all of the paths and do whatever you want with them. So you can do weighted edges. You can do typed edges. You can ask for specific types of edges. You can ask for almost anything. You can put a second, you can put a path. You can ask for a path from the matrix to Cloud Atlas to something else by just adding another dash bracket set dash parentheses. It supports several different patterns, several different things. This will let you you can sort and search to some extent using some more complex queries. Great stuff here. Any more questions with this one? Again, Neo4j, good stuff.
Is there any mechanism for enforcing some sort of schema on this?
You can set attributes to be required by indexing them. And I think you should be able to do that, where you can say that all movie nodes must have a title, and then you will be forced to include a title. Otherwise, it won't be able to put it in there.
Can you enforce relationships in the same way? Could you say, like, all movies must have one and only one director and one or more actors? I don't know.
So I don't think you can. I don't think you can enforce that it has a relationship. I think you can enforce. I want to say you can enforce like maximum number of relationships. But I don't think you can enforce it to have a relationship because of how you would have to enter the data. So in order to do the relationship, you need to put the node in there first, and then link the relationship. So I don't think you can say put this node in here and make sure it has a relationship already. I think you can do
maximum number.
I think you can do max.
Or cannot have, like, a movie can't have a movie. Well, I guess it could have a sequel, but like.
No, we're NoSql.
I mean, sequelant.
This is a NoSql database.
It's sequelant. Thank you.
The best movies are.
So yeah, I don't know if you can necessarily constrain the relationships that well, in that they have to exist or they don't have to exist. But you can certainly enforce attributes there. We have any other questions? Okay, everyone's gone silent. So let's go to the concluding notes slide. This is great. So the first bullet, the most important thing. If you take anything from the stuff I've been yammering about, is look at your data first. Look at what you want to do with your data, then pick a database. Don't start the project saying, I'm going to use MySQL because I know MySQL. That's how you screw yourself later. Like, that's not a good strategy. The other big thing is that once you've decided you want to use a Columnar Store, look around, figure out which ones offer what. Some of them will offer different perks. And then I have a list of the four types. And I have this link here in case, because I was looking for like memes, so I wanted to meme this up, right? It didn't work very well. Let's just which way's the other screen? I don't. Okay. Anyone use a Mac that can like scroll this better? Where'd it go? Where did my link go? I lost it. I had a link just a second ago. Disappeared. Okay, hang on. Let's go back. Where did the PowerPoint go? Try this again. Oh my god, I hate this so much. Connor, I don't like your computer. Just want to point that out.
Okay.
Great. Can we go?
It's not going to show up.
Hmm.
Click back over there and then hit escape on the presentation or something.
Shit.
Escape.
Escape. Oh, can't even tell if I'm clicking it.
You want to just describe the memes?
Oh, it's to the right. It's to the right, Connor. You lied to me. So I'm like looking for database memes, right? So what's the first thing you do, right? You type into Google database memes, right? And so you start looking through this, and you're like, well, what is there? There's nothing. They're awful.
Yeah, if you could email it.
And don't use Access. Access is terrible.
It's true.
But what type of database is Access, Chris?
Awful.
What if it's good for my data?
Find a different one.
Find
I'm
different data.
extremely disappointed in this.
Right?
There,
Like,
there should be like a drop the base meme.
For
like,
some reason,
what does this have to do with databases?
For some reason, I really like the Good Heavens Look at the Time one. It's so bad, it's good.
You know,
It's just a complete non sequitur.
it's so shitty. I like that.
Awful.
I think
Anyway.
we should put a sequel on our programmer humor. Don't you hit there?
Anyway, the last slide is just another slide for questions. If there's anything that I didn't talk over very well, anything that Connor's raising his hand
Yeah,
instantly.
so could you touch on like the big data Hadoop ecosystem real quick and sort of what that is and where it falls in this database?
So Hadoop is built okay. Apache's got this big set of tools that's known is the Hadoop ecosystem, and within the Hadoop ecosystem, everything is pretty much running on top of HDFS or some other distributed file system. And what HDFS is it's the Hadoop distributed file system. Basically, your operating system has a file system. It likes to store files in its particular way. And HDFS lets you store the files on different machines. So you can set up a cluster of nodes, and they act like a single file system. And with that, you get some replication benefits. It's kind of like a standard file store. And then you can build things on top of that. So one of the big key concepts with the big data and the HDFS is the concept of map reduce. And if you're not familiar with that, it has two phases, the map and the reduce. What?
What order do you do that?
Well, using my intuition going off the name, I would say you map first, then reduce. So essentially what map reduce will do for you is that you can take data from all these different nodes and run a mapping function over that to condense the data, and then send it to a reduce function, and the reduce function can give you an answer. So let's go back to calculating the age for a whole bunch of people. I've got this Hadoop distributed file system set up with thousands of files spread across, maybe 200,000 nodes, right? It's just huge. It's absurdly huge. And I want to figure out what the average age is of all of my people. To do this, normally, we'd have to send all of the records from all of the nodes to one place, to one single machine where it could just run all that calculation. This will not work when your data gets bigger than your RAM. And also, you don't want to send that much data across the wire. So what you do is you run a mapping function, and you get a subset of an answer on each node, and then you take all of those, and then you conglomerate that in the reduce function. So that's the map reduce architecture. And Apache has built a whole metric ton of tools on top of this. And I could probably do a whole nother presentation on that if anyone's actually interested in that. But some of the more notable ones, you've got Pig is great for processing data. And as their slogan go, pigs eat anything. You can throw data at it and it will just consume whatever. And it can process data and it can dump it into databases. Hive is a store that runs on top of HDFS that supports a SQL interface. So that's a fun one. You can use Scoop to scoop things out of one database and put it in another one. That's fun. You've got stuff like Storm, which can run on top of it. And if I'm not mistaken, Storm is the one where you can set up different nodes and have each node process a little bit of data and send it along. So one of the things that you can do with Storm that's cool is you can say, subscribe something to, subscribe to, say, a Twitter feed, right? And so it gets live tweets, and you can process them through nodes in kind of like a neural net looking system, one at a time, so no one node gets bogged down. You can funnel your data places. The whole thing about Hadoop and the big data is how do I process all of the data all the time efficiently and quickly? So a lot of your stuff, you send it through Hadoop, you can process it, and then you can send it off to like a Columnar store to just hold on to it forever. And the common one that gets used with that is HBase, because it gets built right on top of HDFS quite well. That's a very brief overview of it. I could do more on the tools later if that's actually a desired thing. So if you want to hear more about that, yeah, throw a message in Slack. If not a lot of people say that, shoot me an email or something. Yeah. Anyone else have any wonderful things you'd like me to talk about? I could sit here and yammer for days. No, not hearing anything.
All right, good stuff.
Another question to comment. That multi-master architecture that you were talking about with Cassandra, it is available in SQL as well, actually, in traditional relational databases. If for some reason you come across needing that solution, and remember this conversation, Galera gives you multi-master configurations for MySQL and MariaDB. I'm not sure if it works with Postgres.
No, that's not a very common thing it offers, so that's good to know.
Cool. Well, thanks, Chris and Lewis, for the content today. That was awesome. Next week, there is no meeting next week. We are skipping next week and resuming the following week. So our week 4 will actually be on July 11th. And I'm working with a couple different options for main topic there. I think Tom, if I'm not mistaken, had volunteered to do cool news. Tom, are you still okay with doing cool news on July 11th?
Yeah, I got to get you a better way to contact me ahead of time, though.
Okay, yeah, that's fine. We could talk, but so we'll do Tom with cool news on the 11th. And then last but not least, poll results. So the question was, what are you doing for 4th of July? The most top-rated answer, leave it to the computer scientist, was null. Okay, well, cool. I think that concludes the Cool Code Consortium meeting for today. We should have the slides up later today, and if you have any questions, yeah, make sure you message Chris, you message in general, and we can try to get those answered. So, also we'll see, no promises, but we may be able to get a YouTube recording of this up later in case anybody wants to watch it. So, we'll see. All right, thanks, guys.
I like the second most popular answer. Who else clicked on that?
Was it Connor?